Recent earthquakes in the Philippines have reminded us of an important question. Why do some buildings survive while others collapse? In this presentation, we will explore the science behind earthquakes, the engineering principles used to design earthquake-resistant buildings, and the steps we can take to protect ourselves and our communities. Earthquakes happen without warning. The Philippines is located along the Pacific Ring of Fire, one of the most active seismic regions in the world. Thousands of earthquakes occur every year. It is important to remember that earthquakes themselves do not usually kill people. Most casualties occur because buildings collapse or objects fall during strong shaking. The Earth's crust is made up of large tectonic plates that are constantly moving. Sometimes these plates become locked along faults, and stress gradually builds up. When the stress becomes too large, the fault suddenly slips and releases energy. This energy travels through the ground as seismic waves, causing the shaking we feel during an earthquake. When the ground moves, the foundation moves first. The upper floors try to remain in their original position because of inertia. This difference in movement causes the building to sway back and forth. The taller the building, the more noticeable this movement can become. A good comparison is a tree bending in the wind. Buildings may collapse for several reasons. One of the most common causes is weak structural design. Older buildings may not have been designed according to modern earthquake standards. Problems such as insufficient reinforcement, weak connections, and poor detailing can significantly reduce a building's ability to resist earthquake forces. Even a well-designed building can fail if it is not built properly. Poor concrete quality, missing reinforcing steel, construction shortcuts, and inadequate supervision can all lead to serious weaknesses. Earthquakes often expose problems that may have remained hidden for many years. A soft-story building has one level that is significantly weaker than the floors above it. This often occurs when the ground floor is used as an open parking area, while the upper floors contain walls and partitions. During an earthquake, the weak level attracts large deformations and may collapse. Every building has a natural vibration period. If the frequency of earthquake shaking matches the building's natural period, the movement can become amplified. This phenomenon is called resonance. It is similar to pushing a child on a swing at exactly the right time, causing the swing to move higher and higher. Modern earthquake-resistant buildings are designed according to the strong column, weak beam philosophy. Engineers intentionally design beams to yield before columns. This allows the building to dissipate energy through controlled damage while preventing the collapse of entire floors. One of the most important components of an earthquake-resistant building is the shear wall. A shear wall is a reinforced concrete wall specifically designed to resist lateral forces caused by earthquakes and strong winds. Without shear walls, buildings can sway excessively, suffer severe damage, or even collapse during strong shaking. Think of a shear wall as the backbone of a building. Just as our spine helps keep us upright, shear walls help keep a building stable when earthquake forces push it from side to side. They provide stiffness, stability during strong ground motion. Shear walls dramatically reduce building movement. Benefits include smaller drift, better occupant comfort, reduced structural damage, improved earthquake performance. This is why many modern buildings contain reinforced concrete cores around elevators and stairwells. If you have ever seen a building under construction, you may have noticed a large concrete box rising ahead of the floors. That concrete box usually contains elevators and stairwells. It is often the building's primary shear wall system. Can shear walls prevent all damage? No. Even buildings with shear walls can experience cracking and structural damage during major earthquakes. However, properly designed shear walls greatly improve the chances that a building will remain standing and protect its occupants. The purpose of a shear wall is not to make a building indestructible. Its purpose is to help the building withstand earthquake forces long enough for people to escape safely. In many earthquakes around the world, well-designed shear wall buildings have saved countless lives. When you see a concrete shear wall, you are not just looking at a wall. You are looking at one of the building's most important life safety systems. Modern building codes require earthquake-resistant design, ductile detailing, strong connections, and proper reinforcement. The goal is not necessarily to prevent all damage. Instead, the primary objective is to prevent collapse and protect human life. No one knows exactly when the next major earthquake will occur. It could happen tomorrow, next month, next year, or decades from now. What experts can estimate is the likelihood of future earthquakes over long periods of time, but not the exact moment they will occur. The best defense against earthquakes is preparedness. Before an earthquake, prepare an emergency kit, secure heavy furniture, and know your evacuation routes. During an earthquake, remember the safety procedure: drop, cover, and hold on. Stay away from windows and avoid using elevators. Many people believe engineers design buildings so they will never crack during an earthquake. In reality, modern seismic design focuses on life safety and collapse prevention. A building may experience damage and require repairs, but it should provide occupants with enough time to evacuate safely. Earthquakes cannot be prevented, and they cannot yet be predicted. However, their impact can be greatly reduced through good engineering, proper construction, public awareness, and community preparedness. The goal is not to stop a building from moving. The goal is to allow it to move without collapsing. Stay alert, stay prepared, and stay safe. Thanks for watching. If you like this video, please like, share, and subscribe. See you in the next video.